Okay, this is the lesson for Chapter 9, Section 5. It's about what we call hyperbolas. Alright, so the goal is to learn the relationship between the foci, intercepts, asymptote of a hyperbola, and the equation of a hyperbola. Okay, so let's start off with the definition of a hyperbola. And again, it's the set of all points P in the plane such that the difference between the distances from P to two fixed points is a given constant. So what does this mean? This means if you have a hyperbola which looks like this, okay, and we've got foci here and here, let's say that's F1, that's F2. Alright, and we draw the distance from this point here to there and to there. Say that's D1, that's D2. And then we draw the distance from this point here to there and there, and we'll say that's D3 and D4. Alright, so what does that mean? That means D2 minus D1 is equal to D4 minus D3. The difference is in them. So hyperbola looks like this little shape here, there, that's a hyperbola. Okay, so we'll just start by defining all the little pieces of a hyperbola before we move on. Okay, so let's draw our grid, and let's start with one type of parabola first. Here's our first type of parabola. Let's say it looks like, and we're only going to deal with parabolas that open around the origin. So these are centered at 0, 0. Okay, so it looks like this. What's happened here is there is some box in between the parabolas, like so. That box is A units from the center to the edge. It is B units from there to there, so from the center to the top, and then it is C units from the focus, okay, to the center. Okay, and so for these, what we have is we always know that C squared is equal to A squared plus B squared. Okay, now the formula for this particular parabola is x squared over A minus y, or A squared, minus y squared over B squared equals 1. Okay, and again, the distance A is the horizontal radius, and the B is the vertical radius, just like our ellipses. Now we also have these little things right here, there and there. Those are called asymptotes. Okay? Asymptotes are these imaginary lines that sort of guide where our graph looks. So we start here and we draw a curve that way, draw a curve that way. We start here, that way, and that way. And this particular asymptote is a horizontal, or this particular hyperbola is a horizontal parabola, and that's because it looks like this. It opens left to right, and x squared minus y squared. Okay, we want to think x squared minus y squared is horizontal. Okay, for a vertical hyperbola, again, we have this little box right here. We've got these asymptotes that go there and there. What happens is it starts here and goes out like that, and then here and here. Okay, so if we define these things, okay, again, I like to keep A constant. A is my horizontal radius. B is my vertical radius. And then C, we'll note, again, is the distance from the focus to the center. Okay, and the form of this equation is y squared over b squared minus x squared over a squared equals 1. Okay, and again, same thing here. C squared is equal to a squared plus b squared. And this is a vertical hyperbola because it's y squared minus x squared. Okay, so, and remember it's a hyperbola as opposed to an ellipse because we've got the subtraction. Alright, so let's look at a couple more facts about this. Okay, so we've got two different equations, x squared minus over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. Remember, this is horizontal. This is vertical. Alright, few things. A, again, is equal to the horizontal radius. B is equal to the vertical radius. C is equal to the distance from the center to the vertex. And we always relate them as c squared is equal to a squared plus b squared. Now, on top of that, we have asymptotes. Asymptotes are always the form y is equal to b over ax, or y is equal to negative b over ax. Okay, and so we'll see how that works in the center, but just remember that b is our horizontal radius, or b is our vertical radius, a is the horizontal radius, and it goes to the corner of the box. So from the center, it goes up b, right a, and or down b, right a. So that goes to the positive b over a and negative b over a. Okay, so the pertinent information we'll talk about next. Alright, if you want to find, or not really find, but we want to graph the hyperbola and state the pertinent information. Okay, so what you'll do is you'll go through this, you'll draw your box. Okay, so you go origin first, right, start the origin, A left and right, B up and down. Okay, now you draw your box. Okay, then you draw your asymptotes. Okay, and that's through the corners of the box. 3, you sketch your graph. Doesn't have to be particular, just make sure it hits at the corners, hits at the vertices, and goes the appropriate direction. Now, the pertinent information, you want to state vertices, co-vertices. I'm going to state the foci and the asymptotes. Okay, and so one thing I didn't list before is if you have a graph going there and there with this little box in between, vertices are here and here, okay, and then your co-vertices are on the left and right side. So co-vertices, vertices. Whereas if I have it horizontal, we have this little box here. My vertices are here and here, and my co-vertices are there and there. Okay, and the foci are always inside the actual graph part. So let's look at some problems.